Hello, I'm Brian McCaw. I'm from XL Wellington. We're here with Katelyn Johnson from GNS NIC to talk to you about the Wellington ice core plant, which is critical to GNS, I believe, and XL have maintained for quite some time now.
Hi, I'm Katelyn Johnson. I'm a scientist at GNS Science. We're here today at the National Isotopes Centre in our ice core facility. So my team and I travel all the way down to Antarctica to collect ice from the Antarctic ice sheet. So we drill long cylinders of ice and bring it all the way back here where they're stored in our freezers at -35. We use this ice to study how climate has changed in the past, and the results of this ice core study helps us understand how climate may change in the future. So our main ice core is from Roosevelt Island, so that's in the Ross Ice Shelf region, and that core is the main core that's stored here. It's 764 meters long, and currently we're using ice that has been melted, and we analyze the little tiny particulates in it, such as sodium, chloride, potassium, calcium. All those different ions help us understand how climate has changed in the past.
XL looked after the refrigeration plant, which maintains the temperature in these rooms behind us here, which you'll get a walk through. Room A and Room B both at -35, and there is another room, storage room, or a lab I suppose you call it, at -19, and then a couple of 5-degree rooms, or a 5-degree room and a air-conditioned, cooled antechamber where you walk through into the main room. Yeah, it's a critical plant. Obviously it's cost millions of dollars to get the ice out of the ice in here to this facility, and it's just making sure that that is kept at temperature, otherwise all the molecules are lost.
When you bring an ice core back from the field, in particular, we need to keep the ice below -20. Above -20, the ice and properties of the ice start being affected, and that can really hinder our ability to attain a climate record from the ice itself. In particular, when this ice core was brought back from Antarctica, it took teams several months of working 12-hour shifts in the cold lab, which is held at -18, where they cut the ice and cleaned it, bagged it, and prepared it to be processed in our warmer laboratory. So the ice core that's currently being stored, or the main ice core that's currently being stored, which is the Roosevelt Island Climate Evolution Project, the last field season for that was in 2014. So this ice core is taken from an area in the Ross Sea region. Understanding how climate has changed in this area is very important, not only for New Zealand, but for the world. And this core is taken from an area where there aren't many records, so it fills a critical gap in our understanding of the region. We have about 24 hours before we need to decide whether or not we move the ice somewhere else, just because that critical temperature at -20 is really when it starts affecting the records. Once you guys get called, we're on call monitoring our temperatures and see if the problem can be fixed, and if not, just constantly working with the team to ensure it stays safe and cold.
So closed up, it's just like a chili bit. So we have to get to site fairly quickly and turn off the things that create heat, like evaporator fans, heated floor, defrost elements, even lighting and other elements will generate heat. So make sure those are all turned off until the power's restored or the refrigeration problem has been rectified. From the call, it's constant communication with the team here to monitor the temperature, tell them where we're at with the repair or how it gets restored or something's going on, and then a decision needs to be made closer to -20 whether to take all the ice out of here and put it into the storage freezers, container storages.